This episode of Mathematics with Mr. Richardson has been brought to you by Hilton Hotels and Resorts, downtown Anchorage, Alaska. Reminding you, at Hilton, if you're not satisfied with your stay, let us know and we'll make it right. A complex fraction is a rational expression that has at least one fraction in its numerator or denominator, or both. Here are some examples. So on the left we have a rational addition problem, two fractions being added together as a numerator, and then another fractional denominator. To the right you can see we have a four-story fraction. I see a couple of binomials and a couple of constants. And on the right, all kinds of things, binomials, trinomials, single term monomials with a variable, constants. One way you can simplify a complex fraction, such as this, is to multiply the numerator and denominator by the least common denominator of all the rational expressions. You can also simplify a complex fraction by combining the fractions in the numerator and those in the denominator. Then multiply the new numerator by the reciprocal of the new denominator. And don't worry, we'll see some actual examples of this in a moment. Example problem 4. Simplifying a complex fraction. What is a simpler form of the complex fraction? 1 over x plus x over y is the numerator, 1 over y plus 1 the denominator. So again, this is a complex fraction. One method we can use is to multiply both the numerator and denominator by the least common denominator of all the rational expressions and simplify the result. So in order to multiply by the least common denominator of all the rational expressions, we would need to identify what that is. So I'm seeing a 1, an x, and a y. Those three different values represent our denominators, and that would mean the least common denominator would be 1 times x times y, or just xy. So multiply the numerator and denominator by xy, simplify, and find y plus x squared over x plus xy. And the second method we can use is to combine the expressions in the numerator and those in the denominator. Then multiply the new numerator by the reciprocal of the new denominator. The first step in this second method to combine the expressions in the numerator and denominator, but here goes. 1 over x plus x over y over 1 over y plus 1 equals, well, we think about what we would need to multiply by in order to simplify the numerator. And on the left it would be y over y, and on the right x over x. Of course, those lead us to that common denominator of x times y, allowing us to then combine. Note the denominator. We have a denominator of y, and in order to get a common denominator, we would have to multiply 1 by y over y. Performing that multiplication, then adding, dividing the numerator by the denominator of the fraction, because that's now possible, multiply by the reciprocal, because that's equivalent to dividing, right? Division of fractions. Just invert and multiply. And finally, divide out the common factor to arrive at the same simplified version as we saw in method 1. Please keep in mind that sometimes it may feel as though I've rushed through examples to you. Keep in mind that all of the work is here, laid out very nicely with explanations of the steps. At any point, feel free to pause the video, or any videos, in order to examine the steps, make sure they make good, clear sense to you. Perhaps ask for assistance or clarification from a classmate, from myself, or from any of your other resources. Just make sure you understand the problem before moving on. And your chance to show that you have got it. Question 1 of 2. What is a simpler form of the complex fraction x over 1 over x plus 1 over y? Work carefully and make your selection from the choices below. And question 2 of 2. What is a simpler form of the complex fraction seen at the right? Work carefully and make your selection from the choices below. Example problem number 5. Let's apply this stuff to real life. Using rational expressions to solve a problem. Fuel economy. A woman drives an SUV that gets 10 miles to the gallon That's miles per gallon, or mpg. Her husband drives a hybrid that gets 60 miles per gallon and looks really cool. Every week, they travel the same number of miles. They want to improve their combined mpg. They have two options on how they can improve it. Option 1, they can tune the SUV and increase its mileage by 1 mile per gallon and keep the hybrid as it is. Or option 2, they can buy a new hybrid that gets 80 miles per gallon and keep the SUV as it is. Which option will give them a better combined mpg? Alright, so the book lines this problem out nicely for us. Again, what we should think on the left, what we should write on the right. We know that miles per gallon is really just a rational expression. We would have a numerator representing miles, a denominator representing gallons. And so since we're talking about the sum of miles between these two vehicles and the sum of gallons of fuel spent between these two vehicles, it makes good sense to write what we see here at the right. Combined miles per gallon will equal the SUV miles plus the hybrid miles, so the sum of miles traveled, divided by the SUV gallons plus the hybrid gallons, the sum of gallons of fuel consumed. Let x represent the number of miles each drives in a week. Consider now our two options. The tuned SUV gets 11 miles per gallon. The hybrid gets 60 miles per gallon. Option 2, the SUV gets 10 miles per gallon and the hybrid gets 80 miles per gallon. The gallons used by each vehicle are miles over miles per gallon. Note that's just another way to write this. Write the variable expressions for each option's combined miles per gallon. And so we're really just translating each of these options that we've written in words above into complex fractions. Since both the woman and husband drive the same number of miles, x can represent the number of miles driven by each. So therefore we have x plus x as our numerator. Recall that represents the SUV miles plus the hybrid miles. And we have x divided by 11 represent the miles driven by the user of the SUV over the miles per gallon of the SUV, plus x over 60, a similar fraction representing the hybrid. And on the right-hand side, option 2, something very similar. Of course, using the statistics given in option number 2. At this point, we have two problems of simplifying complex fractions. Using the techniques that have been demonstrated so far in this section, we would just need to simplify. You may pause now, work through the steps carefully, ensure that you understand them, but each of these reduces to the figures shown below, which represent approximately 18.6 miles per gallon for option 1 and approximately 17.8 miles per gallon for option 2. Therefore, option 1 gives the better combined miles per gallon. And your chance to show that you have got it. Suppose option 3 is to buy a new hybrid that will get double the mileage of the present hybrid. The SUV mileage stays the same. Which of the three options will give the best combined miles per gallon? You may want to rewind the video to consider the example one more time or to grab the details as you work out this problem. And it's time to begin your lesson check exercises. Here are problems 1 and 2. Pause now if interested. Questions 3 and 4. And finally questions 5 and 6.